So now we're going to verify that our system is operating correctly on the DC side. We want to confirm that the right amount of current is flowing on each source and output circuit. The inverter should be maximum power point tracking. So if it's maximum power point tracking, we should see the IMP value from our source circuit. So that's what we're going to be looking for. Each circuit is mounted at the same tilt and orientation, so the current should be the same for each one of them. Now, the amount of current that's flowing is directly related to the amount of irradiance that's on the array right now. So we're going to have to use our pyranometer, our irradiance meter, to measure the amount of irradiance that's on the array, and then we're going to use our DC clamp-on meter to measure the amount of current that's flowing on the wire. So next we're going to use our irradiance meter to measure the amount of irradiance that is on this array. I make sure I have the calibrated cell of the unit in the same plane as the module. And I find that this array is receiving 875 watts per meter square. So before we even open up this combiner box, we want to have an expectation of the current that we're going to see on each circuit. So we looked at a spec sheet for our module, and we found that the IMP value is 7.78 amps. But that's at standard test conditions. When we measured irradiance, we found 875 watts per meter square, which gives us an irradiance factor of 0.875. So I take my 7.78 amps at IMP, multiply that by my irradiance factor of 0.875, and that gives me an expected value of 6.8 amps on each source circuit that I'm about to measure. Now, the output circuit would be from the three source circuits that are in parallel in this box. When they come together in parallel, that gives me 23.34 amps at standard test conditions. But we're not at standard test conditions. We measured 875 watts per meter square. Irradiance factor of 0.875, 23.34 times 0.875 gives us an expected value of 20.4 amps on our PV output circuit. So let's open up this box and confirm that we're seeing our values. This test needs to be done while the system is in operation. So I can't open up the DC circuit. I need to leave the system operating, so I need to defeat the handle to open up the box while the system is still in operation. So again, you want to make sure you have the proper PPE on before you run this test. And we're going to look at our source circuits. So we're going to make sure we have a DC clamp meter. We set it to amps. We zero it out before our measurement. So all the strings are measuring about 7 amps, which is normal. So I'm seeing what I expected in this system. System seems to be operating at its maximum power. Now we're going to look at the output circuit of the system. We know that since there's three source circuits in parallel, and we're at 875 watts per meter square, we should see about 20.4 amps on this output circuit. So again, we're going to get our meter set properly. And I like to test the positive and the negative because they're pretty easy to get to, and it's a good way to tell if you might have a problem in your system. The current on the positive and the negative should be equal, and if it's not, you might have a problem. There might be a fault of some kind. But here, everything was equal, and it looks like the system is performing correctly.